I hope you're ready for a mental challenge because the indirect pathway with the basal nuclei is just that. The major players, we have the motor cortex, we have the basal nuclei, which include the caudate nucleus, lentiform nucleus, which includes the putamen, globus pallidus externus, globus pallidus internus, subthalamic nuclei, and thalamus. And then the last player is down here in the midbrain called the substantia nigra pars compacta, which releases dopamine as the neurotransmitter. So let's start at the top. We got the first one up here in the motor cortex. It's going to come down and synapse onto the caudate nucleus and the putamen. We're just going to kind of look through this circuit. So at the putamen, we have GABAergic neurons waiting there. Glutamate's released, so it's going to stimulate these inhibitory neurons. So this inhibitory neuron is going to travel from the putamen a short distance to the globus pallidus externus, where it inhibits this other GABAergic neuron. So you inhibit an inhibitory neuron, so that frees up this excitatory neuron to release more glutamate from the subthalamic nucleus. It's going to release more glutamate up here on this GABAergic neuron. So you're stimulating an inhibitory neuron here. So that's going to increase the amount of GABA released at this synapse in the thalamus. So that's going to inhibit this stimulatory neuron, and that's going to lessen the glutamate released up here, and that's going to turn off, any kind of movement. Whenever we want to move, we have to have help from dopamine. So dopamine in the direct pathway, I made another video on that. It's stimulatory because it binds to a different subtype, a dopamine type 1 receptor. But in the indirect pathway, it stimulates a type 2 dopamine receptor, and it has an inhibitory effect on that. So when we want to move, we have to turn this indirect system off. And one way we do that is with dopamine. Dopamine will come up here and it'll inhibit this action of stopping a movement. And that'll help facilitate initiation of movement. If you think about it, patients suffering from Parkinson's disease, that's what they suffer from. A big hallmark of that disease is not being able to initiate a movement. So you can give them Sinemet. Sinemet is a drug that you give someone with Parkinson's disease to increase the amount of dopamine in the brain. The way it does it is you take it in an oral form, and it's a precursor called L-DOPA. It's one step away from dopamine, but L-DOPA is the only one that can cross the blood-brain barrier. Dopamine can't. So once L-DOPA gets up in the blood, in the brain, then it gets converted by L-DOPA decarboxylase into dopamine, and it can have its effect in the brain. But Sinemet also has carbidopa within it, which turns off L-DOPA decarboxylase in the periphery. That way, you can have all that L-DOPA get into the brain and not turn into dopamine outside the brain.